We're going to be looking at the coordinate system, which really just has to do with looking at graphs. So graphs using the Cartesian coordinate system are employed often in math and many other disciplines as a way to display paired data and look for relationships. In the context of how people work in groups, we can compare their comparisons of communication and work styles. Another way to think of coordinate systems would be to think of latitude and longitude. So that actually, when we think of like the map, it is a coordinate system as well. So there are a few things that I want us to point out about the Cartesian coordinate system, and this is a picture of it right here. We have it broken into 4 different quadrants. So the quadrants are quadrant 1, 2, 3, 4, and they're in Roman numerals. If you prefer, you can think of them as 1, 2, 3, and 4. And an easy way to remember which quadrants are which is to think of it in terms of a C. If you start here and you draw your C, you can think of it as the coordinate system. And so you start here, 1, 2, 3, 4. That is how you can remember them. The x-axis is the horizontal line. The vertical axis is the y-axis, or that vertical line. The origin is at the point 0, 0. Any x values are to the right, that are positive, are to the right of the origin, and any negative values for your x values are going to be to the left. For your y values, or for the second part of your ordered pair, because your ordered pair will always be written as x and then y, anything that's positive will be above the origin, and anything that is negative will be below. A variable is a letter used to represent an unknown quantity that can take on various values. For example, if the ordered pair xy, x and y are the letters that represent numbers that can change. Okay. The first thing that we want to do when we plot an ordered pair is we want to think about if we go to the left or to the right first. So, our x value tells us if we go left or right. If it is a positive value, we will go to the right. If it is a negative value, we will go to the left. The other number tells us if we go up or down. If it is a positive value, we will go up. If it is a negative value, we will go down. So, looking at 3, 4. This one, I'm going to go 3 to the right. So I'm going to always start at my origin, and I'm going to go 3 to the right, and then I'm going to go up 4. So this is point A. The other thing that I want to do is I want to list if it is at an axis or a quadrant. So in this one, it is in quadrant 1, because these are the quadrants that we have. It is in quadrant 1, so we can put quadrant 1, and I can even just abbreviate it. One other thing that I do want us to do here is I want us to go back to this visual right here and kind of list a few other things that are special about these specific places. In quadrant 1, your x and your y value will both be positive. Both of those will be positive. In quadrant 2, your x value will be negative, but your y value will be positive. In quadrant 3, they will both be negative. And in quadrant 4, your x value will be positive, but your y value will be negative. And there's also something special about the x and the y axis. If a number is on the x axis, it will have a number value for the x value, but it will have a 0 for the y. And it's flip-flopped when it's on the y axis. It will have a 0 value for the x, and for the y, it will have a number. So when we look at part B, it says we want to plot it at 5 and then 1.7. So I'm still going to go, it's to the right 5 and then up 1.7. So I'm going to go 5 to the right and then up 1.7. So that's going to be almost at 2. So this is B. This one is also in quadrant 1. For C, it's at 2, -4. So I'm still going to go to the right 2, but then I'm going to go down 4. So this will give us point C. This we can see is in quadrant 4. For D, you might be thinking, oh, this one's a lot trickier because it has a fraction in it. Remember that the easiest way to address a fraction is just to divide. So take -5 divided by 2, so you get -2.5. So that is where I'm going to go for the D point. I'm going to go -2.5, so I'm going to go -2.5, and then it's -4, so I'm going to go down 4. So that's point D, and that is in quadrant 3. For E, my x value is 0, so I'm not going to go left or right at all. I'm only going to go up 1. So this is point E. And we can see that that is on the y-axis. For F, that point, I am going to go to the left 3, but I'm not going to go up or down at all. And I can also see that that is on an axis, and this one is on the x-axis. For example 2, we're just switching it up. We are just taking the points that are already plotted, and we're going to write what their actual coordinates are, so what they are in terms of where they're at with x, y, and then also which quadrant they're in. So remember that this is quadrant 1, 2, 3, and 4. So when I look at point A, it went 2 to the right and up 3. So it's at the point 2, 3, and it's in quadrant 1. For point B, it is to the left 4 and up 1. So it is at -4, 1, and that is in quadrant 2. For C, that is down 5. Oh, sorry, we want to first say if it goes left or right. So it is to the right 1 and down 5. So it is at 1, -5, and that is in quadrant 4. And for D, this one is to the left 2, but it doesn't go up or down at all. So it's at -2, 0, and we can see that it's on the x-axis. Okay, the parts that I skipped over are just more detailed instructions for how we actually went through the examples that we did. This wraps up section 1.2. If you have any questions, let me know.